Okay, we're going to turn to page 500 and we're going to hit the skills practice first. I think we had to get 1 through 4 done on that. And you're going to see a lot of these matrices here. It's just to organize information. That's really all it's used for. So, number 1. In the following two-person zero-sum game, zero-sum means there's a winner and a loser. The payoffs represent gains to row player 1 and losses to column player 2. Okay? So, player 1 is arranged by rows, and then player 2 is arranged by columns. I'm going to write in your book. Hopefully that's okay. Okay, what's the max and min strategy for player 1? Okay, here's how you find a max and min. Remember, this is player 1. You look at all his possibilities in his rows by row. And then what you ask yourself is, okay, what's the minimum in this row? 3, 7, 2. The minimum's 2. What's the minimum in this? Okay, minimum. It's 1. What's the minimum in this? And it's 4. Now, it's called max and min because now with all my minimums, I pick the highest one. It's called your maximum, and that's 4. Now, what row did that come from? Came from the third row. Okay, so that's your answer is letter C. Basically, what he's looking at is, okay, what's worst case scenario? Because these are all the money amounts you could win. Okay, payoff means money amounts. What he says is the worst possible option that I could pick is, well, 2 in this row, 1, and then 4. So max and min means I would want to pick that third row because, yeah, I might not win much money, but at least I'll be guaranteed anything less than, I'll be guaranteed that I don't make anything less than $4. Okay, that's what a max and min is. Okay, number 2. In the following two-person zero-sum game, the payoffs represent gains to row player 1, losses to player 2. So that's 1 and that's 2. The min and max strategy for player 2. Now here's player 2. Now it says max. So what we do is we take the maximums. Okay, so 8. And then 9 in that column. Remember, the player 2 goes by columns. And then here's 4. Okay, now what's the, now it's called mini-max, because now out of your maximums, you take the lowest, okay? And that's your mini right there, and that's 4. So in that table, the max and min is 4, and the mini-max is 4, and those are the same, okay? So when the max and min and the mini-maxes are equal, what we have is called a saddle point. I know that's not part of your answer, but that's a term you need to get familiar with as we move on through this assignment. It's called a saddle point. 4 would be our saddle point. And that saddle point occurs in the third row in the third column. Okay, number 3. This is multiple choice. In a two-person zero-sum game, suppose the first player chooses the third row at the max and min strategy, and the second player chooses the first column in the mini-max strategy. Based on this information, which of the following statements is true? The game definitely has no saddle point. That's wrong. How am I supposed to know the saddle point? It's going to be B. Because there's no way I know the saddle point if I don't know any of the values. Okay, so that's that one. Okay, number 4. Consider the following 3 two-person zero-sum games where the payoffs represent gains to row player 1 and losses to column player 2. Okay, so it's 1 and 2, 1 and 2, 1 and 2. And then it goes on to ask which games have a saddle point. Okay, so here's how you figure that out. So let's look at player 1, okay? And what we need to do is take the mini maxes, okay, or the maximins, sorry, the maximins from his row. So what's the minimum of 3 and 6? It'd be 3. 5 and 4 is 4. So remember, I took the minimums. Now the maximum of the minimums is 4. Now let's look at player 2. Let's find his mini maxes. Okay, so what's his mini maxes. So the maximum's 5 and the maximum's 6. So since he's doing maximums, he should go with the lowest one, and those aren't the same. So the first one's not going to be an answer. The first game does not have a saddle point because they didn't pick the same thing. For the maximins and the mini maxes were not the same. Okay. Now let's look at game 2. Okay, so let's look at this guy, the row. Remember, he's going to look at his minimums, -1 and 0. And he's going to pick the highest, which would be 0. Because gaining $0 is better than losing 1. Okay, now the guy in column 2, he's looking at the maximums. He's thinking big, so he sees 2 and 3. So which one of those is your smallest? So 2. Again, those were not the same. So that did not have a saddle point. Now let's look at game 3. Okay, here's all the rows for player 1, and he's looking at the minimum. So 5, -1, and then he sees 5 as a minimum here, and then 0. Well, the highest is 5, okay? That could be either in the first row or the third row, but it's the highest. Okay, now let's look at the columns, and let's look at the maximums. So 8, 5, 7, and 5. So your maximum is 5. These ended up being the same, so game number 3 is the answer. That's the only one that had a saddle point because they occurred. Now the saddle point could occur in different places because we have 5 as your minimum here, or here it could be in first row or third row. First column, fourth column, too, okay? All right, now let's talk about 13 and 14. Here's what this means, baseball. You know baseball, so here's what this means. If the batter guesses fastball and the pitcher throws a fastball, the batter gets a hit 40% of the time. That's what a 400 batting average is. If the batter guesses fastball but the pitcher throws a curve, the batter's only going to hit 200. He's going to get a hit 20% of the time. If the batter guesses curve and the pitcher throws a fastball, he's only going to get a hit 10% of the time. So that's a batting average of 100. Because batting average is always out of 1,000. And then the curve, if he guesses curve and he throws a curve, he's going to hit 500. So that means half the time he does that, he's going to get a hit. Sometimes he might hit it hard. It's just right at somebody. So what's a pitcher's best strategy? A, throw more curves and fastballs, throw more fastballs and curves, throw about the same number of curves and fastballs. Now what you need to do with your pitcher is this, okay? Pitcher goes by columns. So what you take is you take 0.4 and you're going to use a variable and you're going to multiply that by P. Plus 0.2, and you're going to multiply that by 1 minus P. Okay. Now, also, let's look at the curveballs. You got 0.1, you're going to multiply that by P. and then 0.5, you're going to multiply that by 1 minus p. Now, the reason it's p is because you know how a percent's always out of 100? So let's say the p is 30%. Well, then the other one would be 70%. Okay? It's always 100 minus that number, and that's why you see 1 minus p. Okay, now what we need to do is simplify both of these. Okay? So that's going to be 0.4p. 0.2 times 1 is 0.2. 0.2 times p is 0.2p, so minus 0.2p. Okay, and now we combine like terms. 0.4p minus 0.2p is 0.2p plus the 0.2. Okay, now let's look at this right here. That's going to be 0.1p plus 0.5 times 1 is 0.5, and then 0.5 times p is 0.5p, so minus 0.5p. So 0.1 minus 0.5 is negative 0.4p plus 0.5. Okay, now this and this, I need to find out where they intersect. So what that essentially means is I set an equation where those two expressions are equal to each other. So 0.2p plus 0.2 equals negative 0.4p plus 0.5. Okay? Then what I do is I add 0.4p to both sides because they're on opposite sides. And then I get the 0.2 and move it over here because I want the p's on one side, the non-p's on the other. So it's going to be 0.6p and 0.3. Now I divide by 0.6. Now that's a fraction, so reduce it. It's 1/2. So here's his strategy. 1/2, and that's fastball, because that's your first one. And then what's 1 minus 1/2? If half of them are fastballs, half of them are curveballs. Okay. Okay, so the pitcher should guess half and half. Okay, it could be half the time the pitcher's going to throw a fastball, half he's going to throw a curveball. Okay, now the batter. So it's going to say throw the same number, so C is your answer. Okay, number 14. Here's another one. Okay, the batter's optimal strategy. Now the batter's right here. Okay. Okay, now when we're talking about the batter's optimal strategy, now we decide what the pitcher's going to do. Okay. We decide what he takes into account what the pitcher's going to do. Okay. Because now the batter goes by columns. Okay. It's like you're just. And let me explain. The reason why with the pitcher we went by rows is because the pitcher's trying to guess what the batter's going to look for. Okay, so we use the batter as kind of row numbers. But now that we're using the batter's trying to guess what the pitcher's going to throw. So it's the same thing, but now I go by columns. Okay, so I go 0.4 times P plus 0.1 and then 1 minus P, okay? And then the other one, it's going to be 0.2P plus 0.5 and then 1 minus P. So it's going to be 0.4P, okay, plus 0.1 minus 0.1P. 0.2P plus 0.5 minus 0.5P. Now combine like terms, so it's going to be 0.3P plus 0.1. That's simplified. Now 0.2 minus 0.5 is negative 0.3P plus 0.5. Now we set those equal. So 0.3P plus 0.1 and then negative 0.3P plus 0.5. So I add 0.3P to both sides. and I minus 0.1 from both sides. Now I have them arranged. So it's 0.6p, 0.4. Now if you reduce that, that's going to be 2/3. So the batter's exact optimal strategy is to guess that the pitcher is going to throw 2/3 fastballs. And what's 1 hole minus 2/3? It'd be 1/3, and then 1/3 curveball. Okay? So his optimal strategy, the answer is that, is to guess more fastballs than curveballs. Okay, next video is the skills, is the exercises.